Hey everybody, Jacob here from Haimer Manufacturing. In this video, I'm going to be going over how to use an edge finder and the Tormach here to indicate one of my bottle openers, and I'm also going to set the Z offset for the work offset, and I'm also going to show you how we do that in PathPilot. I'm going to walk you through the whole process. So let's get started and hope you guys enjoy. As you guys have probably noticed that my last couple videos have been more informational rather than machining, because I want to really focus on the kind of the basics of machining and then kind of start getting into more of the toolpaths and the CAM software and showing more videos. I just thought for right now I'd show you guys more basic entry-level stuff for anybody who's new to the trade and would like to see another video on how to do those things. So I hope you guys do enjoy. I enjoy making these videos. I enjoy sharing what I know and just kind of sharing everything I can so people can also learn and grow. So hope you guys really do like the videos, and I'm going to keep them coming. So when I come over here, I'm going to go to the main screen. I'm going to type in the spindle RPM. So I'm going to type in 1,000. I'm going to hit enter. It's going to save it. So from here I can do forward, reverse, or stop. Well, it's an edge finder. It doesn't really matter if it's forward or reverse. So from here I can click it, and it's just going to start the spindle. And from there I can just use my jog handle or my jog wheel, and I can wheel it around and get it to where I want, and then I can just click these and zero them out. When I want to stop the spindle, I'll hit stop. It'll stop the spindle. So we're going to start off in the controller. I'm going to set my work coordinate down here so I can start doing XY. So if you see for G54, I have bottle opener op1, G55 bottle opener op2. So I'm going to change this to 54, which is already in 54, but I'll show you guys how to do that. You're going to type an MDI in the main program. You're going to type G54, enter, and it'll change this to whatever you tell it to. So if I do G55, then that changes to 55, but we want 54. So we're on 54, so now we can actually put the edge finder in the mill and we can start indicating the part in. So I'm going to position my edge finder on this side of an X of the part, and I'm going to touch off here, zero out. So I'll do that now. So you want to make sure that this diameter is underneath the top. Not all of it, but a good amount of it, about 3/4 of it, is underneath the top surface, because you want as much contact as you can to get an accurate reading. If you go too far, you're going to be up in this other diameter, or might actually hit the radius of the edge finder. So I'm going to spin this at 1,000 RPM. So I'm going to come over, change the RPM to 1,000, and I'm going to do forward. You can do reverse too, doesn't matter. And in X, I'm going to be in 1,000 step over on the jog handle. Just be very careful which setting you're in, because you're going to have to look at your PathPilot to see what you're in, because if you're in 100 thousandths and you click, you could just break the edge finder real easy. So I'm going to slowly move it. You're going to see that this diameter is not going to wiggle as much. It's going to start being cylindrical with this other diameter. So right there is pretty good. So I'm going to change it to 10th reading right now. So I'm going to bring it in gently, 10th by 10th. So right there, it looks like it's run really true. So we're going to wait till that diameter offsets. So right there, it just kicked off. It actually just moved back. So I'm going to move Z up. I'm not going to move anything else. I'm just going to move Z. And I'm going to hit X0, zero it out, and I'm going to go to the other side of X, lower it down, and repeat the same process. So right there, I went way too fast and I went past it. So I'm going to sneak up back on it. So this part I'm indicating X is in the middle of the part. So since I zeroed off on the one side and I moved over and I touched off on the other, between those 2 points it's 3.29. Well, I want in the middle of that distance, so I'm going to come over here and put -2 to divide by 2, enter. It's going to automatically divide that in half for me, which is a really nice feature on PathPilot. Some machines have this option where you can input both points and it'll do the math for you. I know Maury's do that, some of the older ones. Haas's, I don't think you can, but yet again, most Haas's have probes. I'm going to show you again in Y of touching the part off, and you can actually be able to see this diameter actually move off. So right there we're pretty close, so I'm going to switch to tenths now. Now I'm just going to slowly move it in. So right there it kicked off, so I'm going to go Z up. I'm going to zero Z out, or not Z, I'm sorry, Y. I'm going to zero Y out. I'm going to move to the back. So right there it kicked off. So I'm going to raise Z. I'm going to turn the spindle off. So I'm going to do the same thing that we did to X for the Y. So right there is the distance between the 2 points that we took. So I'm going to come over here and I'm going to divide by 2. So right now we just set the work coordinate for X and Y, but I'm going to show you a different way to touch off X and Y. This is us finding the center, but what happens if you're not doing the center? What happens if you're just doing the top left corner of the part? I'll show you that right now. So we're going to touch it off just like normal. So right there, the diameter just kicked off. So I'm going to move Z up. I always have a habit of moving Z up because I just don't want that edge finder to sit there and just keep spinning against that part while I'm trying to adjust the work offset in the computer. I do the same thing for manual mills. So we just touched off the left side of the part. We didn't move X at all we did was move Z up. So I'm going to zero X. So that puts us half the diameter of the edge finder off the stock. So that edge finder is 200 thou. So that means from the center of the spindle we are 100 thou off where our work coordinate should be. So you can do one of two things. You can come over here and put -0.1 and enter it, and then that tells us that we are -100 thou left of the part. Or what you can do is you can zero this, and then you can actually use the hand wheel, move it over 100 thou, and you're just going to keep track of it on the DRO on the controller. So you're just going to move it until it reads 100 thou. So right there, that reads 100 thou positive because we moved it to the right, so the center of the spindle is on the edge of that part. So then you're just going to hit 0, and now we are on the left edge of that part. Center line of the spindle is on the left edge of that part. So we're going to do the same thing for Y. It's the same principle, same theory, same everything. Same thing, I'm going to zero out Y. Now I'm just going to tell it that it is positive 0.1 because this is the top side of the part. So this is positive, this side would be negative. So I'm telling it it's 100 thou above where it should be. So now 0 is the edge of this part, 0 is the edge of this part, so that corner is our work coordinate system. I'm going to tell you how to touch off Z now on your part. So I put a 4 flute 3/8 end mill in there, which is my tool 23. I touched it off. So if we come over here to offset, go to tool, right there's tool 23. So that's my 3/8 steel 4 flute, and there's the length offset. So down here in the bottom it says T. T is for your tool number. So I'm going to put in tool 23. And if you guys can see, this tool length right here changed to what's in this column. So that tells the machine that from this spindle face to this tip is that distance, which is 2 inch, 919 thou and 5/10. So what we're going to do is we're going to take the bottom of this tool and bring it to this top face of our part. But our work corner is actually 10 thou below that. But we can't do that, get there without shattering the end mill. So what we're going to do is we're going to touch the top of this off, zero it, and then move it 10 thou. So let me get the camera set up and I'll show you how to touch it off. So I'm going to show you 2 different ways to touch it off. They're both really the same way. You're just going to bring the tool to the top of the part. So you're going to get close, but you're not going to have it touch this material. I'm going to put it in thou, and I'm going to slowly bring this down and take my piece of paper and just keep moving it back and forth, and I'm waiting till I feel a tad bit of drag from that end mill. So right there I kind of get feeling tighter. I'm going to keep going. It's increasing, it's increasing. I can feel that drag more and more. So right there it's getting pretty stiff. Right there I can barely pull the end mill. So that tells me that that end mill is just barely touching the top of this paper. So that means that I am roughly, paper's about 4 thou, so I'm roughly 4 thou above the top of this material. So I'm going to zero out my Z, and because I have my tool in there, and I have my tool offset pulled up since I told her what tool's in there, the machine's automatically going to say from the top of this spindle to this tip is that offset, but I'm touching the tip of the tool off this. So that machine's going to factor in all that length in already in the work cornet. Be very careful when you do this. You got to be very careful, make sure you don't smash the end mill on the part. But you also want to make sure you have the right tool number put in the machine, because if you don't, you're going to crash the machine when you go to come into the part. And on these parts I only have 20 thou from the top of this jaw above, so I got to be very accurate with my Z. So right there I'm at Z0, but that's not actually Z0. I am 4 thou above the stock. So I'm going to go to work, description, Z. So I'm at 0, but I'm going to tell it I'm actually 4 thou above it because that paper. So I'm going to type in 004, and if you notice, it's going to change it here in the work system, and it's going to say we're 4 thou above it. But I also need to remember that I have to go 10 thou below the material. So what I'm going to do is, so I am 4 thou above the material, but my 0 is actually 10 thou below. So I'm going to come over here. So this reads 9 inch, 655 thousandths and 9/10. Well, my offset is actually supposed to be 10 thou below the stock. So I'm going to change this first 5 to a 6. That is going to move the work cornet 10 thou below where I told 0 was. So that means that my 0 is now in correlation with what my cam is. So right there it says we're actually 14 thou above it. Technically we are, because that paper and the 10 thou we just added. But we're only 4 thou above the material right now, because I just want my work cornet below the top of that material, so when the face mill comes in, I'm decking all that top material off and not leaving any raw stock. Another way that I was taught in high school and college, which my teachers called the safer way of touching off Z, was you want to actually touch the material off. What you would do, you'd take a gauge block, a 1, 2, 3 block, you'd put it down on the material, and you take your tool and you'd put it below the top of the gauge block. So right there, that gauge block can't go underneath it. So I'm going to put it in tenths reading right now. I'm going to move this up slowly. And I'm just going to keep trying to wiggle this gauge block up underneath this. So right there, I just slid right underneath it. So I'm going to lower it just a couple more tenths. Keep lowering it. So right there, I can't go back underneath unless if I push. So I'm going to raise it a couple tenths. So right there, I can just barely get underneath it. So that tells us that we are the width of the gauge block above the part. And if we look right here, I still have my 0 on the top of the stock. I went back and changed it so I could show you guys both methods. So that is 1388. This gauge block is 138. So I'm within 8/10 of my other way of doing it. So both are within a thou. That is a great kind of reassurance that we're doing it right both ways. So kind of like the same way with the paper, we would have zeroed off the top of the gauge block, and then we would have went whatever the gauge block was down. So we'll do that now. We'll zero it, but we want to tell the machine we were actually the width of our gauge block above it, which is 0.138. So we are 138 thou above the material, which we are because that gauge block barely fits underneath it from the top of the stock. And then from there, we would just go up here and we would change our Z by the 10 thou to get it below the surface. Hope you guys enjoyed the video. I hope you guys learned something. I hope you like it, and I hope you guys come back for more videos. So thank you so much for watching, and stay around for the next video.